This is video on kinematics of particles. This is the fifth video. Here we are going to look at some problems on curvilinear motion. Now we're going to use some formulas directly which are derived in part 4, of the video. Part 4 of kinematics of particle. So it would be advisable to look at that video, that is fourth video on kinematics of particle, or what we call part 4, before you actually look at these problems. Okay. Now, first problem goes like this. A car is traveling along a circular curve having radius 50 meter. If the speed is 16 meter per second and is increasing uniformly at 8 meter per second square, determine the magnitude of its acceleration at this instance. Now you have to note that it's clearly curvilinear motion. They are clearly saying circle is traveling along a circular curve. So these are the three equations we'll be using all the while. But here you see rho is directly given. Radius is a circular path, no other curve. So we don't have to use this equation because we have rho directly. Rest of the things we can get from the text. For example, speed is ds by dt, 16, and acceleration is 8, d square s by dt square. And these numbers we put in this acceleration formula. So we get 8 et plus 16 square by 50 en. And et and en are perpendicular. So for this is a vector equation. We can work out its magnitude by 8 square plus this 16 square by 50 whole square added and taken under root. We will get 9.5 meter per second square. Next problem. A jet plane flies along the vertical curve having radius of 800 meters. If his speed is uniformly increased from 180 meter per second to 230 meter per second in 4 seconds, determine the magnitude of his acceleration at the instant the plane's speed is 200 meter per second. Alright, so again these formulas you are using. Again, radius is directly given, so don't have to really bother about this. Use rho directly. And then ds by dt is directly given as 200 because that's the instant where you have to work out total acceleration. And acceleration along the path, this data is there. D square s by dt square is 230 minus 180 by 4, rate of change of speed. So all these numbers we put in our acceleration formula, we get the total acceleration and this magnitude. Next problem. A skier travels with a constant speed of 6 meter per second along the parabolic path, whose equation is y is equal to x square by 20. Determine his velocity and acceleration at the instant he arrives at A. Neglect the size of the skier in the calculation. Now here, for the first time, the path is not circular and we need to work out the radius of curvature at point A. So this is point A where x is 10 and we are going to use these three equations. So let's first work on this equation in order to find out rho. So dy by dx you make, d square y by dx square you find out. Then you are given ds by dt as 6 and it's constant, so you also automatically d square s by dt square becomes 0. Now these you can use to work out rho. That is dy by dx, d square y by dx square, you put it here, and x, when you get out here, you put it as 10 because at A, x value is 10. So you'll get your rho. Once you have rho, put in this formula to get your acceleration. That is what is asked. And we can show it here. See, tangential is 0 and normal is 1.27. Okay, next problem. This says position vector of the particle is given by r is equal to 2t square I plus 4t square j, where t is in seconds. When t is 1 second, determine magnitude of normal and tangential component acceleration of particle and radius of curvature of the path. See, first, we all know that since we want tangential and normal component of acceleration, we got to use these this formula. So first we start with given r. We make we realize from here that x is 2t square, y is 4 by t square. Eliminating t, we can get equation for the curve, and using this we can get dy by dx and d square y by dx square. Now mind you, we need to work out this rho. We are going to work out rho first at t equal to 1. You must realize that if t equal to 1, x is 2. X is 2. So here, whenever x comes, you have to put value of 2, and then you can get your rho in clear number, 5.59 meter. That is the value of rho at t equal to 1 or x equal to 2. Then dr by dt is known to you if you differentiate r. Magnitude of dr by dt is ds by dt. So we find that, and then once we find ds by dt, normal component, that is ds by dt whole square upon rho, will work out to this, and d square s by dt square, all you have to do is differentiate this and put, and this all we are working out at time t equal to 1. So put t equal to 1 and you will get this tangential component of acceleration. Negative sign only means is deceleration along the path. Now next problem. It says a particle moves according to the equation RT is equal to 50 cos 4t square I plus 50 sin 4t square j, where the distances are in centimeter and the time is in second. Find velocity, tangential and normal acceleration. Alright, we have our equations. We are not bothering about rho because it's a circular path. This equation tells us it's a circle. So R is clearly 50. The rho is clearly 50. You have R and then you do dr by dt. Mod of dr by dt is ds by dt. And ds by dt, if you simplify this, comes to 400t. Differentiate it. So the velocity, one part which was wanted is 400 t et, because velocity is always tangential. Now d square s by dt square, you differentiate this and use acceleration formula. Rho you are going to use 50 because it's a circle. So use acceleration formula and get your acceleration, tangential component and normal component. So these were some of the collection of problems which we solve using the curvilinear motion equations. Thank you.